In this module, we will be looking at how an A340 pilot and the aircraft computers interface to ensure safe and accurate flight, with minimum workload for the crew. For clarity, most references in this module will be made to manual flight inputs. However, the references apply equally to automatic flight, unless stated otherwise. A side stick or an autopilot sends a message to the flight control computers, demanding an aircraft maneuver. The flight control computers process the demand and send it to the control surfaces. The processing uses preset limitations and instructions called laws. The aircraft responds conventionally to the movement of control surfaces. Normal law is modified depending on the flight phase. It operates in 3 modes. Ground mode operates on the ground when the aircraft is electrically and hydraulically powered. Controls are conventional. Flight mode operates in the air after a gradual transition from ground mode just after liftoff. Will be discussed in detail later in this module. Flare mode modifies flight.
Control surface deflection is directly proportional to control yoke deflection. The same yoke input produces a higher rate of pitch roll at high speed, a lower rate of pitch roll at low speed. Control surface deflection is not directly proportional to side stick deflection. A side stick deflection gives a rate demand to the flight control computers. The flight control computers set control surface deflection to meet the rate demand. For the same side stick input, the control surface deflections will be large at low speed but small at high speed. A side stick input is a rate of roll demand in roll, load factor G demand in pitch. Yaw control is electrically controlled on A340 600 and 500 and remains conventional on A340 200 and 300. Remember, the A340 responds conventionally to the movement of control surfaces. The resulting aircraft response is then fed back to the flight control computers.
The computers process this feedback and adjust control surface deflection to ensure that the maneuver rate demand is executed accurately. This means that control surface deflections may be altered with no change in side stick position.
In flight mode, if, for example, you wish to execute a left turn, you set the required attitude and then return the side stick to neutral. The neutral side stick position demands 0 rates of pitch and roll. The flight control computers will maintain the set attitude until you use the side stick to demand an attitude change. Throughout the maneuver, there are no pilot trim inputs.
Turn coordination and Dutch roll damping are automatically provided in normal law. Pilot inputs on the rudder pedals are not required. Normal law provides a number of airborne pitch protections. They are maneuver protection, pitch attitude protection, high angle of attack protection, high speed protection. In lateral control, there is only one protection, which is for bank angle. Let's take a closer look at these protections.
In a conventional aircraft, pilots must ensure that structural limitations are not exceeded. However, in the A340 family, load factor protection is available in normal law. Load factor protection prevents structural overstress by limiting control surface deflections through the flight control computers. Full side stick movement is always available. The structural limitations vary with configuration. Slats retracted between plus 2.5 G to minus 1 G. Slats extended between plus 2 G to 0 G.
As with the maneuver protection, if the aircraft reaches the pitch attitude protection nose-up limits, then the flight control computers will override pilot demands and keep the aircraft within the safe flight limits. The pitch attitude protection limits are shown as small green dashes on the PFD. Note that the pitch-up limits vary between 30 and 25 degrees, depending on the aircraft configuration and speed. In the nose-down case, the computers will limit the nose-down attitude at 15 degrees. The high angle of attack protection is designed to prevent the aircraft from stalling and to ensure optimum performance in extreme maneuvers, such as wind shear or GPWS warning recovery. This protection takes priority over all others. This protection displays information against the PFD speed scale. As speed decreases, it reaches VLS, lowest achievable speed with autothrust engaged. With autothrust inoperative or not engaged, the speed can reduce to the first level of angle of attack protection, V alpha prot, which is shown at the top of the amber black band, barber pole. The flight control computers will maintain the speed at V alpha prot. If engaged, the autopilot will disconnect.
If the pilots override V alpha prot using the side stick, the speed can reduce to V alpha max. In normal law, the flight control computers will maintain V alpha max, even if a pilot holds a side stick fully aft. Pitch trim is inhibited. In the protection range, the normal law demand is modified, and side stick input is an angle of attack demand, instead of a load factor demand.
Provided the autothrust is serviceable, the speed is unlikely to reduce to V alpha max before the alpha floor protection is triggered. This is indicated by an alpha floor indication on the FMA and also on the engine warning display. If the pilot releases the side stick at V alpha max, the speed will return to and maintain V alpha prot. The protection we will look at now is the high speed protection. It is designed to prevent the aircraft from exceeding maximum speed. These protection limits are displayed on the PFD speed scale. VMO/MMO is shown at the bottom of the red-black barber pole. Green dashes indicate the speed at which the protection is activated. When the airspeed Mach increases above the VMO/MMO, an overspeed ECAM warning is triggered, as shown on the autoflight chapter. If the airspeed Mach increases to the protection speed, the autopilot will disengage, and the flight control computers send a pitch-up command to the control surfaces to prevent further acceleration. The flight control computers will permit this speed to be momentarily exceeded for maneuvering, if necessary, but will then return to the protection speed. Notice that the pilot cannot override the automatic nose pitch-up. Under normal law, bank angle protection limits the angle of bank to 67 degrees. Shown by green dashes on the PFD.
If the pilot holds full lateral side stick, bank angle will increase and maintain 67 degrees. The flight director, FD, on the PFD will disappear if the bank angle exceeds 45 degrees.
If the side stick is released at any time when the bank angle exceeds 33 degrees, the aircraft will return to and maintain 33 degrees bank angle. The FD will be displayed again on the PFD when the angle of bank reduces to less than 40 degrees. Auto trim is inhibited above 33 degrees.
Note: if high speed or angle of attack protections are active, bank angle is limited to 45 degrees. In case of high speed protection, the aircraft will return to wings level if the side stick is released. We will now study the reconfiguration laws in the next module.